upload to Blackboard. So after class, you can still watch it. Question. This is quiz 6. This is question 1. Question 1, we have 4 questions. This is a multiple choice. So question 1 is, according to the first law of thermodynamics, energy is neither lost nor created in any energy transformation, right? This is the first law of thermodynamics. So you should choose A. This is straightforward. No explanation I can explain for this. It's a very straightforward question. And question 2, a closed system can exchange what? Only energy, yes. Open system can exchange energy and material or mass. So A, right? So the open system. Closed energy only, a closed system can only exchange energy. So choice is C. If I put isolated system, then neither energy nor mass. That should be D. Right? In the test, I may put different system there. So you need to understand all 3 different systems. Open system can exchange energy and mass with the surrounding. And a closed system can only change energy with the surrounding. Isolated system, neither energy nor material or mass can exchange with the surrounding. Question 3. The work done on the surrounding by expansion of gas against external pressure. Gas expansion against constant pressure, right? What is the work done? The work done always this, negative P times V, always this. This is always correct. So you should choose A, always true. Okay, this is always true, either expansion or compressing. Okay, expansion is the initial value of volume is smaller, expand at a larger volume. So delta V will be positive, then work is negative because system does work on surrounding is negative. But if this is compressing, final volume becomes smaller, then delta V is negative. Another negative, work is positive. Because compressing is surrounding does work on system, work is positive. So whatever expansion or compressing, this process, this formula always correct. Question 4. Endosomic process. Endosomic process, heat is absorbed by the system. Is this correct? Yes. Endosomic process, heat absorbed by system. If exosomic is released. So this is true. So you choose A. Okay. You're okay for this 4 multiple choice. Okay. Then the rest we need to show work. Okay. I labeled very clear. You must show work for the following calculations. Each step worth some point. And this one is for reaction P4 react with oxygen, produce P4O10. Delta H is negative 13 kilojoule per mole. So A, if 250 grams of P4 react with excess oxygen, see how much heat will be absorbed or released. Of course, released because here negative is released, right? And based on this equations, every 1 mole P4 will release this amount of heat. And this 250 gram P4, so you need to convert more. Right? With excess oxygen, this means P4 is limiting. In order to calculate anything, you need to use a limiting reagent, right? That's very clearly oxygen is excess, so P4 is limiting. And we just convert mass into mole first because this balance equation tells you every 1 mole P4 produces this amount of heat. How can we convert mass into mole? I always wrote in that corner many times, right? Mass divided by molar mass. So 250 is a mass. Then divided by molar mass. What is molar mass? Use the periodic table I provided you. P, phosphorus, atomic mass is 30.97. But be careful, you have 4 P atoms there. So you need to multiply by 4. So this is the molar mass of P4. So gram cancer becomes more. Then every 1 mole produces this amount of heat, so multiply by this. This will be total energy will be released. Okay? Use a calculator, you can easily get it. It's negative 80.5 unit is kilojoule. That's more. Cancer is more. Unit is kilojoule. This total heat will be released. So negative energy is released. So release energy, this is exosomic process or exosomic reaction. If positive, then endosomic. Positive means absorb heat. This is endosomic. Okay, okay for this one. It's really straightforward. We have very similar example sure during the class, just a different number, right? Question 3. Here you earn a specific heat S is 0.444 joule per gram per Celsius degree. Asking how much heat released when 365 grams of air at 280 degrees Celsius dropped to 5 degrees Celsius. Ask you how much heat will be released. Okay, so this is a really straightforward. The Q as the heat is M times S times delta T, right? M mass 365 grams. S 0.444 joule per gram per Celsius degree. And delta T, which one is final? Delta T, final temperature minus initial temperature, right? From here to here, of course, this is the final. 25 minus 280 Celsius degree. Cancel this per Celsius degree. This gram cancel this per gram. Left over. That's a joule, right? So use calculator, you can easily get this is negative 41325 joule. Okay. We showed a very similar example during the class, right? By the way, other section, this one is a little bit different. Some students are getting lost. Okay. I would like to show you here. Okay. other section, steer arm bar, specific height is same. Mass 78 gram. And I tell you 554 joule heat absorbed for arm bar. Initially at temperature means initial temperature, right? This arm bar initially at a temperature 25 degrees Celsius. Ask you, what is the final temperature will be? Can you solve this problem? A little bit different, but unfortunately, many got lost. Josh, can you solve this?
Maybe.
Which formula you need? Solve any calculation problem, always formula first, right? Which formula you going to use? Yes, still use this formula, okay? So Q equal to M times S times delta T. Then this is a Q, right? Equal to M78, right? S times delta T.